Assalamu alaikum. Myself Golam Mahbuba. ID 1716022. Third year, first semester, session 2017 to 18. My presentation topic is power factor. Power factor is the cosine of the angular displacement created when the voltage and current are out of phase. It depends on active and apparent power. So we know that the equation of power factor is the active power divided by apparent power, which is denoted by P by S. Power factor can be differentiated as lagging power factor and leading power factor. Lagging power factor, the power factor of the circuit is said to be lagging when the current lags behind the voltage. It lags in inductive circuits, induction motors, coil, etc. are the examples of inductive loads and have lagging power factor. Leading power factor, the power factor of the circuit is said to be leading when the current leads the voltage or voltage lags behind the current. The power factor leads when the circuit is capacitive. Synchronous condensers, capacitor banks, etc. are the examples of capacitive loads and have leading power factor. To calculate power factor, we need a power quality analyzer or power analyzer that measures both working power and apparent power, and to calculate the ratio of kilowatt divided by kilovolt ampere. The power factor formula can be expressed in other ways. Power factor equal true power divided by apparent power, or power factor watt by volt ampere, where watts measure useful power while volt ampere measures supplied power. The ratio of the two is essentially useful power to supplied power. The relationship between active, reactive and apparent power is represented as vectors in the form of a triangle called as power triangle. The quantity of active and reactive powers are represented as horizontal vector and vertical vector respectively. The apparent power is the hypotenuse of a right angle triangle formed by connecting the active and reactive vectors. Here the figure of power triangle is shown. The technique of increasing the power factor towards value 1 of an electrical system is called power factor correction. Ideally, current and voltage waveforms should be in phase with one another, and all the electricity drawn from the AC mains should be utilized effectively. However, there is always a current or current by voltage lag that leads to lower power factors due to the reactive components present in a majority of circuits. Without power factor correction, the voltage supplies draw current in high magnitude pulses, which has to be smoothed out. This is achieved using power factor correction techniques. Figure below shows the current and voltage waveforms before and after power factor correction technique. The application of power factor are: a high power factor becomes necessary in a transmission system which reduces transmission losses and improves voltage regulation at the load. Its improvisation is important in the systems in which additional load is added, and thus system losses is considerably reduced. It is increased to make the motors run efficiently and to avoid overheating. The advantages of power factor include: 1. Reduces electricity charges. 2. Power factor correction lowers the amount of pollution resulting from releasing carbon emissions into the atmosphere. 3. Power factor correction lowers heat generation in cables, switchgear, transformers and alternators. 4. Voltage drop is considerably reduced. The disadvantages of power factor include: if the power factor is low, then current produced is high, which results in large voltage drop. The efficiency of the system reduces if the power factor is low. To transmit high current at low power factor, then the conductor required should be large. Thank you.